Hey y'all! In this video, we're going to continue our adventures in composite modeling, and we're going to create this little 9-inch diameter serving dish. It's a double-sided project, and all of the components of this dish come from the Vectric Clipart Library. We're going to use 3D tabs, and I'm going to show you how to create this little decorative foot here on the bottom of this dish. Now, even though I'm demonstrating this project in Aspire version 10.507, this model can be created and cut using VCarve Desktop and VCarve Pro. Let's go ahead and get into a new session of Aspire and create this double-sided project. We'll come over here to Aspire and we'll create a new file. Now I managed to score a piece of 10-inch wide walnut that is 15/16 of an inch thick. So I've set up a double-sided job with a width of 10 inches in X, 10 inches high in Y, and I have my thickness of 15/16 of an inch. I'm going to set my Z0 to the material surface on both sides when I flip the material over. For layout purposes, my XY datum's in the center, and when I flip my material over, I'm going to flip it from side to side. I am 3D modeling. However, the models that I'm using and the bits that I'm using, I don't need real high resolution, so very high is plenty. And we'll go ahead and click OK. Now the first thing I want to do is get down here into my clipart gallery. And I've gone into my clipart folder, and we'll go into domes and dishes. And I want a nice gentle slope on this dish. So I'm going to select this 45-degree dome and dish. I'll double-click it to put one out in the middle of my material. Then we'll head over to the Modeling tab. Now, I'm working on the top first, so I need to make sure that this is a dish rather than a dome. But before I do any of that with the properties, I'm going to set the object size. My material is 10 inches wide. I'm going to go for an outside dimension of 9 3/4 inches. I want a 1/4 inch rim all the way around this dish, so I'll need to make this dished area a 1/2 inch smaller in diameter than the outside diameter. So I'll make sure I have my anchor point set to the center and link XY checked. And I'm going to enter 9.25 inches. And we'll click Apply. And there is my 9 1/4 inch diameter. Right now it's currently a dome. I'll go ahead and close that. And with it selected, I'm going to come up here into the properties. Starting from the top here, I'm going to call this the dish. And I'm going to change the combine mode to subtract. So now it's a concave shape that's being carved into the surface of the material. Now, right now, my shape height is 1.3, almost 5 inches high. That's thicker than my material is. So I'm going to bring this down. Right at the moment, I'm going to say 0.5. And that's just simply to get it thinner than the material. I won't know exactly how thick to make this until I get the bottom modeled. But this will keep it from interfering with our 3D view in just a minute here. So I'll set my shape height at 5. We will be coming back to change this. I'll go ahead and close Now, with my model selected, I need to go ahead and create a vector boundary around that. And that's going to be for machining. I don't want my 3D roughing or my 3D finishing to go beyond this vector. I don't want to carve across the top rim of the bowl. So we have this vector, we have our model. Now I need to add a 0 plane. If we take a look here, tile the 2D and 3D views, we have our dish shape, but we also have these ragged edges. Now again, when I'm cutting a concave shape, I want to add a 0 plane above that model to give me a visual representation of the surface of the material and to fill in any rough, jagged edges here in the model. We'll go back to a straight Z view on our 3D view. And I'm going to go back and maximize my 2D view and bring that back up to the center. Now it's time to go over to the Drawing tab and add our alignment dowel holes. So we'll go over here into Draw Circle, and I am going to be using 1/4 inch dowel. We'll come over here, and I want them to be slightly off to the side. I'm going to be placing some 3D tabs here, and I want to be able to use screws to mount this material. So I don't want these dowel holes to interfere with those screws or those tabs. So I'll just put another one over here off to this side and another one over here. So now these should not interfere with my profile cutout, and they shouldn't interfere with any screws or those tabs. And I'll go ahead and close this. Now immediately after creating those dowel holes, I want to select them, then right-click, copy to other side. Now when I go look at the bottom of my material, I have the corresponding holes on the other side. Let's go back to the top. I have my alignment holes, I have my vector boundary, and I have my model, although we will be coming back to change that shape height. I'm ready to go ahead and model the bottom. So we'll switch over to the bottom. And of course I need to go ahead and put that same dish out here in the center. So I'll double click to put one in the center. Then come over to the Modeling tab. Now again, I want this dome to be 1/4 inch wider all the way around than my dish. So I'll come over here to select Set Object Size. Make sure I'm anchored in the center and Link XY is checked. And I'm going to make this 1/2 inch larger in diameter than my dish. So I'll go 9.75, click Apply. Now when I tile my 3D view, I have a dish on one side and a dome on the other. There's my dome. Here is my dish. And here in red, you can see that 1/4 inch diameter rim running around the bowl. Let's go back to a straight Z view, and we'll go ahead and close that. And I'm going to maximize my 2D view again here. We need to get into the properties of this dome now and start figuring out shape heights. So with the dome selected, I'll come up here into Properties, and my Combine mode is currently set to Merge. I'm going to leave it there. I want it set to Merge. And my shape height is 1.4 inches. My material is 15/16 of an inch thick. I'm going to highlight that shape height and delete everything in that blank. And now, since I don't remember the decimal equivalent of 15/16 of an inch, I'll type in 15/16 and then tap the equals button on my keyboard, and that gives me my material thickness. Now, I'm going to try to make this simple, although it's going to sound a little complex. It's easier than you think. This is my material thickness. I'm also going to be applying a 1/8 inch thick flat disc here to create that foot. That's going to be, again, 1/8 of an inch thick. So I want to take my material thickness and I want to subtract 1/8 of an inch. Tap equals, and that leaves me 0.8125. So the height of this is 0.8125. I'm going to take this 12.5 thousandths here, this 0.0125, and I'm going to delete that. That is going to have the effect of creating a gap below the model of 0.0125. And when we get over into the material setup, before we start calculating toolpaths, I'll show you what that means. So I'll just delete those numbers, and that leaves me with 0.8 shape height. I need to remember that, because that's going to come in real handy in just a minute. So I will change the name of this to bowl bottom and close it. Now I need to go back over to the top and select my dish here. And I'm going to go up into the properties. I'm going to select that 1/2 inch that I had, and I'm going to remember that 0.8 shape height of the dome. I want to subtract 1/4 of an inch from that, because I want the material thickness here at the lowest point in the dish to be 1/4 of an inch. That 0.8 minus 0.25 is 0.55, a little more than a 1/2 inch. So when I come over here and tile my 2D and my 3D view, and I'm going to share a little tip with you that I got from the Vectric User Group Meeting this year. And that is, if you look down here at my readouts, down below the model, you can see I have X, Y, and Z readouts. Now watch to the right of that Z readout. When I hold down my control button and move my cursor around down here, you see thickness pops up, and it's showing me that the thickness of my material is right around 1/4 of an inch. So holding down the control key and moving around your cursor, you can get the material thickness once you have modeled both sides. Now I let go and move the cursor around, and the thickness disappears. And if my cursor is stationary and I hold down control, nothing really happens. I have to move the cursor for that thickness to pop up. And I'm just holding down the control button on my keyboard. So I can go ahead and now close this. My shape height for my dish is the shape height of my bottom dome minus the material thickness that I want here. That gives me the shape height of my dish. So with that figured out now, I can go back to the bottom and finish modeling. Let's go ahead and expand my 2D view. Because this is a convex shape, I don't need a zero plane. But now I want to add this flat disc here to the center to make my foot. So I'll come down here to the Clipart tab, And I'm going to use this flat round circle right here. I'll double click that. Come back over to the modeling tab. And I want to make this about 4 inches in diameter. So with it selected, I'll come up here to set size, make sure my anchor point's in the center, link X, Y are checked, and I'll make that 4 inches in diameter. Click apply. I'll close that. Now with it still selected, I'm going to come up here to the properties. And I'll tile my 2D and 3D views here to show you what's going on. And if you notice, right now, I don't have anything here because the combine mode is set to merge. I want to add that foot to the top of this model. So there we go. That's better. But it projects up above the surface of my material. It's thicker. This combined model height is thicker than my material is. So now, let me bring down the shape height to 1/8 of an inch. Let it update. And now we're all set. I'm going to change the name to foot. And we'll close. Go back to a straight Z view. And I'm going to go ahead and come back over into my 2D view. We have just a little bit more 3D modeling to do here. And that is come into our clip art. And I'm going to go into my 3D tabs. And I'm going to go with a 1/4 inch circular tab. I'm going to drag one up here about like so. More or less at a straight line between the corner and my dome here. And I'll hit 0 to rotate that to 45 degrees, just the number 0 on my keyboard. And I'm going to tile my 3D view and take a look here. I think that this tab is shoved too far that way, so I'll grab it in the middle and kind of drag it out a little bit and kind of place it at a 45-degree angle here in straight line. There we go. And I want to be able to see the straight flat end of that tab, so let's back it out a little bit. There we go. That should hold it about right there. That's good. I can just start to see the flat edge of that tab. Maximize my 2D view. Go back over here to the modeling tab, and I want to select that tab. Come up here and check the properties. Shape height is okay. It is set to merge. I want it to merge with this dome. I'm going to close it. And now I want to select it, and I want to create a circular array. I want 4 tabs here. So with that tab selected, I'll go into circular array. I'm not going to touch my object size, but I am going to change my rotation center to the center of my models here. So I want my rotation center to be at X0, Y0. That puts my rotation center right there. I want to rotate these copies. I want a total of 4 around a total angle of 360 degrees. And I'll click copy. And there are my 4 3D tabs. Now I can close this. And I'm going to go back over to my drawing tab. Now I need to create a vector boundary around my dome. So I'll create that vector. And if we come in here and click, we have our vector right there. Now I have one last vector to draw, and that is the area in here that I want to carve out for my foot. So I'll go into my drawing tab and I'll do draw circle, and I want the center of that circle to be at X0, Y0, and I want it to be 3-inch diameter. I want that foot nice and wide here. I don't want the ball nose bit to carve away too much of it. So I want to make it 1 inch smaller in diameter than this foot is. So I'll click Create, then we'll close. These are all of the vectors needed to create this project. So now what I want to do before I calculate any toolpaths, I want to save this project because everything we have going right now is in memory. So let's go ahead and save it and write it to our hard drive. We'll go File, Save As, navigate to the folder I want to save it as, and I will call it 9-inch dish demo. Save. Now we can go over to our toolpath tab. I'm going to cut the top first and drill my alignment dowel holes in the material on the top. Before I do anything else, I'm going to go into Material Setup, and we're going to look at what I've got going on here. My material thickness is 0.9375. Now is the time that I will change my XY datum. For layout purposes, I set to the center because it's easier to lay out based on the center of the material. When I go outside to cut on the CNC, I'm going to set my X, Y, and Z 0 to the bottom left corner. So that's where I'm going to change my datum to now. So all of my toolpaths will be calculated with this being my X, Y, and Z 0. I'm setting my Z0 from the material surface. And here's what I was talking about earlier. If you notice, I have a gap above the model is 0. My slider is all the way up. But look down here in this box, I have a gap below the model of that 12 thousandths of an inch. What that means is, when we go to carve the bottom of this project, during the 3D finishing toolpath, that ball nose bit is going to shave that 12.5 thousandths off of the bottom of the model. So I'll have a nice flat bottom. And all these are correct, my Z-gaps, etc. And I'll click OK. Much like any other two-sided project, the first thing I want to do is cut my alignment dowel holes. So I'll select my 3 circles here, and I'm going to do a drilling toolpath. I'm using 1/4-inch dowels and a 1/4-inch end mill, so I can use a drilling toolpath. If I was going to use 3/8-inch dowels with a 1/4-inch end mill, I would use a pocket toolpath. I don't need to use a pocket toolpath. I can drill, so that's what I'm going to do. I just need to remember to use an upcut bit. My start depth is going to be 0. I want to start at the surface of the material, and I want to drill 1/2 inch deep. The end mill I'm going to use is a 1/4-inch end mill. I'm going to peck drill, retract above the height of the previous pass, and we'll go 10 thousandths of an inch. So it's going to use a peck depth of 1/8 of an inch, and it gets that from my pass depth of this bit. So it's going to peck down 1/8 of an inch, lift up 10 thousandths, go down another 1/8, lift up 10 thousandths, etc. And I'm going to call this Dowel Holes, and we'll calculate. And I'll go ahead and preview. Okay, I'll close my preview, and I'm going to select this vector right here, and I'm going to do a 3D roughing toolpath. I'm going to use a 1/4-inch end mill. Let's go ahead and take a look at this. My pass depth is 0.1. And I have my feeds and speeds. Everything is okay here. I'm going to machine to the selected vector, this one right here. And I'm going to use a boundary offset of 0. I don't want a boundary offset. I don't want this end mill to come out of this dish and go across the rim of my dish. I'm going to use a Z-level roughing strategy, rastering along the X. I'm not going to worry about plunging in ramp moves, and we'll call this 3D roughing. And I'll calculate. And we'll go ahead and preview that toolpath. Okay, with our 3D roughing toolpath created, we can see we're looking good so far. I'm going to go back into this roughing toolpath for just a second because I forgot to mention that I'm using a machining allowance of 20 thousandths of an inch. And what that means is during the machining process, it will leave a minimum of 20 thousandths of an inch. It's going to leave a little bit more out here on these ridges, but it's going to get no closer to the finished surface than 20 thousandths of an inch. We'll go ahead and close our preview, go back into 2D view, make sure I still have that vector selected, and we'll do a 3D finishing toolpath. Now, this is not a detailed model by any stretch of the imagination, so I'm going to use a standard 1/4-inch ball nose bit. It's not a tapered ball nose, it's a regular standard ball nose bit. My step over for this particular project, I'm running with 7% step over. That's smaller than I normally use. Normally I use anywhere between 8 and 10%. But in doing large areas like this, I find 7, sometimes 6% gives me a better finish. There will always be some finish sanding, and this project is no different. But running a slightly smaller than average step over lets me get away with less finish sanding than I normally would. The other way I'm optimizing this toolpath is my plunge rate I have set for equal to my feed rate. Now, these are starting numbers. I can increase the feed rate on the fly outside on the machine once I figure out how this walnut is cutting. Remember, in a 3D carving, the machine always moves at the rate of the slowest axis. So by making my plunge rate the same as my feed rate, all 3 axes will be moving at the same rate. That helps me to optimize this toolpath. I only have 20 to 40 thousandths of an inch of material to remove, so this plunge rate will do just fine. We'll go ahead and say OK to that. I'm again machining to the selected vector. And again, I don't want any boundary offset. I want that bit to stop at that edge. I don't want to go beyond that. I'm going to use a raster strategy with an angle of 40 degrees because I find I get a good finish if it's not cutting with the grain or against the grain, but kind of both and neither at the same time. And we'll call this 3D finish. and I'll calculate that toolpath. And we'll go ahead and preview this toolpath. And with our finishing toolpath completed, we can rock this back and we can see we have a nice gentle slope in here. Now we can close our preview, go over to the 2D view, and we're ready to calculate the toolpath for the bottom. So we can toggle over to the bottom, and again, because it's a double-sided project, the first toolpath we want to run is our dowel holes. So select them, and I'll do a drilling toolpath, and I'm not going to change a thing here. It's all the same. I'm cutting a 1/2 inch deep with my 1/4 inch end mill, peck drilling, retracting 10/1000ths above my peck depth of 1/8 of an inch, and we'll call this Dowel Holes caps lock in spoil board caps lock, and we'll calculate that toolpath. Now, even though I'm drilling these holes into the spoil board and not my piece of material, I'll go ahead and preview them just to make sure that they line up with the holes we drilled in the top of the material. So I'll go ahead and preview, and then come in here. We see daylight through them. I don't see any steps, so they are lined up. So we have our dowel holes in the correct location. Go over here to the 2D view again. And I want to select this outside vector here. Close my preview. And I want to do a 3D roughing toolpath. Again, I'm using my 1/4 inch end mill. I'm machining to the selected vector. This time I do want a boundary offset of the diameter of my end mill, which is 1/4 of an inch. Once again, I'm using a machining allowance of 20/1000ths of an inch, leaving that much material behind out here. And I'm going to use a Z-level strategy, rastering along the X, and we'll call this 3D roughing. And I'll calculate the toolpath. And we'll go ahead and preview it. Okay, and with our preview finished, we can see we have roughed out our shape. Looking good. Now I can close the preview, go back over to the 2D view, make sure I still have my vector selected, and go into a 3D finishing toolpath. Once again, I'm using that same 1/4 inch standard ball nose, machining to the selected vector. I want a boundary offset of 1/4 of an inch. I'm going to use a raster strategy. Now, I could use an offset strategy, but I find I get a little bit better finish if I use a raster strategy, and the difference in machine time is not much. So I'll go ahead and use a raster strategy for this 3D finishing on the outside here. Again, I'm using a raster angle of 40 degrees, and I'm going to call this 3D finish bowl bottom, and we'll calculate that toolpath. Now we'll go ahead and preview this toolpath. Okay, with our 3D finishing toolpath completed, we can see that indeed that bit came along and it surfaced off that 12.5 thousandths gap right here on the bottom of this foot, making it nice and flat. We can also see that it is trying to go through the material right here, which is why we placed our 3D tabs. So we have just a couple of more tool paths to create and preview. Right now we need to machine out the center of our foot here so that we have that rim, that decorative rim. This is another tip I picked up from the Vectric User Group Meeting. For this, I'm going to close my preview and we'll go back over into our modeling tab. And for this tool path only, I'm going to turn off the foot model. It disappears out here. I'll go back over to my toolpaths tab, go into my 2D view. I want to select this vector. Come back over and do another 3D finishing toolpath. Using the same bit, I'm going to machine to this selected vector with 0 boundary offset. This toolpath I am going to machine offset, and we're going to call this 3D finish foot. And we'll calculate this toolpath. And we'll go ahead and preview. And that machined out the center of this foot. Now, again, in Aspire, it would be very easy to model the inside of this foot to look identical to the outside. Not so easy to do in VCarve. So what I can do is I can come along and sand a nice round over into this rim here to knock that sharp edge down and make it look nice compared to this rounded rim out here. So for this toolpath only, we go back over into the modeling tab and turn off this foot model. Warning here, if you have to recalculate any of these other roughing or finishing toolpaths on the bottom or the top, go back over to the modeling tab and turn that foot back on. If you don't, it will machine away this foot completely when you recalculate. So again, turn off this foot here when you calculate this toolpath only. And if you have to recalculate any of these other finishing or roughing toolpaths, go back over and turn it back on. Okay, we have one more toolpath to do, and that is our profile cutout. Now I'm going to bring my cursor down here and kind of look around a little bit. We've cut almost all the way through the material, but I don't want to take a chance on chopping through these tabs. I'm going to cut through them a little bit, and I already know that. So I'm going to look at the height right here of this tab, and it is 8167, 8185. So I'm going to go ahead and use a start depth of 0.82 for my profile toolpath. So I'll close my preview, go back to the 2D view, and I'm going to select this outside vector right here. And I'm going to do a profile toolpath. My start depth is going to be 0.82. I want it to start above this tab. And for my cut depth, I'm going to cut 1/8 of an inch. So my start depth, 0.82. My cut depth, 1/8 of an inch. I'm going to use my 1/4 inch end mill. I'm going to machine to the outside of the vector. I'm not going to do a separate last pass. I am going to add tabs to the toolpath. I am not going to use 3D tabs in this toolpath because if I cut these angles using this 3D tabs, it's going to cut into these too deeply, and I don't want them to chance coming out. I'm going to use a thickness of 3/8 of an inch. Even though these tabs are not that tall, I don't want them cutting too deep into this tab. Okay, I'm going to go ahead and add tabs. I'm going to place one right about here. And that looks good. And we'll calculate that toolpath. We know it's going to cut through our material. And I can take a look. Yeah, it may cut into them a little bit, but we're going to be all right. We'll go ahead and we'll preview that toolpath. And it did shave a little off the top, but we're okay. There's enough of a tab there that it's not going to break loose. Then from there, I can take it loose from the table, cut off my tabs, and sand away the 3D tabs off of the back. We have the decorative foot here. We have a nice gentle slope to this bowl and a nice gentle slope here with a 1/4 inch rim all the way around it. So while it looks very complex to create this bowl, if you keep in mind a few general rules, you can be successful at this on your first attempt. I will type out the formula for figuring out the shape height of the dish and the dome and put them in the description of this video down below. But the thing to remember is to figure the shape height of your bowl bottom, take the thickness of your material, subtract the thickness of the foot, then round it down anywhere from 10 to 20 thousandths of an inch to put that gap at the bottom of the model here. You'll want to machine off just a little amount, just a small amount, to ensure you have a flat foot here. And that will be the shape height of your bowl bottom. After you've done that, to get the shape height of your dish, take the shape height of your bowl bottom and subtract the material thickness you want left behind here. I went with a 1/4 of an inch. If you only want 1/8 of an inch, fine. That's whatever you're comfortable with. But take the shape height of the bowl bottom here and subtract the thickness of the material you want left behind. And that will give you your dish shape height. And again, turn off your foot model to machine the inside of the foot away. Then if you have to recalculate any of these other finishing or roughing toolpaths, turn it back on by putting that check mark back in that blank. Otherwise, it will machine away the foot completely when you recalculate those toolpaths. So, I know this was a long one, but I hope you got something out of this video. And if you did, I do hope you'll give this video a thumbs up. Now, as a reminder, this afternoon at noon Pacific Time, 3 p.m. Eastern Time, I'll be hosting a live Q&A session where we can discuss composite 3D models, 3D tabs, 3D modeling, this bowl that I created here, the foot, any of the tool pathing, anything that I've discussed in this video. That's noon Pacific, 3 p.m. Eastern, right here on my YouTube channel. And I'll put a link to that live Q&A session down in the description box of this video, along with the formula I used to set my shape height for the dish and for the dome on the bottom. So I hope to see you this afternoon. And as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch this video, and y'all take care.